ladies and gentlemen, we're going to do 9.3 today. We're going to continue our work with conic sections. We are going to do the circle today, which in my humble opinion is the easiest of the conic sections. All right, so first we need to go back and remember some vocabulary from geometry. So we're going to do some geo vocabulary. All right. So let's talk about a circle first off, since that's what we're working with today. The circle is a collection of all points in a plane that are equidistant from a fixed point called the center. Okay, and we talk about it being in a plane because it's two-dimensional. If we put it in a three-dimensional geometry, then it becomes a sphere. All right, a radius then is the segment that goes from the center to any point on the circle. Any point on the circle. Okay. So I'm going to park my circle at the origin, okay, lovely circle that it is. Okay, so there's my center, it's at the origin, so that means its coordinates are 0, 0, and then the radius is going to be that little guy, okay. I could show you how to come up with the general equation. So the general equation, actually I'm going to call it the standard equation to be consistent. The standard equation for a circle is x squared plus y squared is equal to its radius squared. Super simple equation, which is why we like the circle. It's developed by calculating the distance of the radius using the distance formula, but for all intents and purposes for us, this is as much information as I'm going to give you. Alrighty, so my radius squared is going to go here. And then as long as my circle is at the origin, then this is going to be the equation. Later in the chapter, we will start moving things around a bit, and then it changes it. But the circle is still the politest of the conic sections. All right, so we're just going to jump right in, and we're going to do example. It says graph by hand. No laughing at my lopsided circles. And you're going to be given y squared is a negative x squared plus 36. And then I want you to identify the center and radius. All right, so if you'll notice, the x squared is on the wrong side of the equation, so I'm going to move it. I'm going to add x squared to both sides, so it's going to become x squared plus y squared is equal to 36. And there you go. The equation's nice and polite. It's located at the origin. So that's going to be my center. So I'm going to put a dot and I'm going to put a C. My radius is going to be the square root of 36 because remember the standard formula has r squared and the square root of 36 is 6. I'm not going to do plus or minus because distances aren't negative. And so then I'm going to say that's 6, 6. This distance is 6 and 6. Oh, it's going to be yucky. Connect the dots. Ooh, there's my circle, and that's a negative 6, and that's a negative 6. Okay, and then there's my radius of 6, and ta-da, done. Circles are super easy. We love circles. All right, I have one more example for you, and then I think it's going to be the fastest video in history. All right, in the next example, I have a point 2, -5, and it's going to lie on a circle. There's the abbreviation for circle, so I don't have to write the word, whose center is the origin. Everything's going to be at the origin for a little while, and then write the standard form of the equation of the circle. Super simple. Okay, so the first thing I'm going to do is I'm going to kind of draw a sketch because again it helps my poor little pea brain to know what's going on. So my circle is going to be located at the origin, so there's my center. It's at 0, 0. Okay, And then I have a point 2, negative 5. So if I do 2, 1, 2, 3, 4, 5, that's a negative 5, that's a 2, there's the point. That means that my circle, us lovely, is going to go through that point. So this point is 2, negative 5. So what I need to do to be able to write the equation is find the radius. And I'm going to find the radius using the distance formula. So my radius is going to equal the square root of x2 minus x1, quantity squared, y2 minus y1, quantity squared. So my radius is going to be the square root of 2 minus 0, quantity squared, plus a negative 5 minus 0, quantity squared. So it's going to equal 2 squared is 4, 5 squared is 25. So my radius is going to be the square root of 29. And if you'll remember the standard formula, x squared plus y squared is r squared, I don't have to simplify the radical, because when I square the radical, when I square a radical, I get the number underneath. So my equation is going to be x squared plus y squared is equal to 29. Ta-da, done. Circles are glorious. They are so much easier. Alrighty, let me give you your problems. Sorry, I'm just kind of laughing because this is so much shorter, easier than parabolas, okay? Alright, in class one day I'll show you how to put the equations in your calculator, but most of the time we're going to be doing these by hand. Alright, so your first problem says graph the equation by hand. Case in point, the equation by hand, labeling everything, and I want to identify the center and radius, which means that in my answer column on a quiz or exam, I would say center and give the coordinates, and then radius and give an answer. So for number A, you're going to have x squared plus y squared is 81. And then your second one is going to be x squared equals a negative y squared plus 40. Also remember that anytime you get a radical for an answer, leave it in radical form, but you always want to simplify your radical. Okay? Second problem, number 2, is going to say write the standard form of the equation of the circle with the given radius and center. Okay, so my center is going to be 0, 0, and the radius is going to be 5 radical 2. One more problem. I want you to write the standard form of the equation of a circle that passes through the point negative 9, 2, and then whose center is 0, 0. So I want you to write the equation of the circle that passes through the point negative 9, 2, and then whose center is 0, 0. That's it. Oh my goodness, it's a 9-minute video. Have fun. See you soon.